Hello, engineers. Hope you all are doing great. I couldn't record video over Elastic Load Balancer due to some issue with my AWS account, but today's session is going to be super exciting for you all. Whatever I have discussed so far in this video series about scale and scalability, we shall be testing our API or server over different scale in this video. So let's see, let's start. I have written two topics here, latency and throughput. Let's see what is latency and what is throughput. Let me write it here. Latency. Latency. What do you understand by latency? So let's describe this in simple terms. Suppose this is the client. Just a minute. Suppose here is the client. Let me make it a small. This is my client. What this client will do? What this client will do? It will simply request a server. This is my server, let's say. This is my server. Now, what client will do? Client will request, and what this server will do? This server will respond the client after processing the request. Okay, this was the request, and this is the response. Response. Okay. Suppose client requested at suppose client requested at 10 10:45 IST. Okay, and client got response at 10:55 IST. At this time, client initiated the request, and then this request traveled to server, then server processed it and returned back the response, and client get the response at this time, 10:55. So what is the difference? What is the difference? It is of 10 seconds, right? It is of 10 seconds. 10 seconds. This is what we call latency. This is what we call latency. So what is latency? It is the end-to-end wait time as seen by client. See, client raise the request, then after raising the request, client have to wait for some time to get the response. And that overall wait is latency. That overall wait is latency. So let me write the definition here. Latency is the end-to-end wait time seen by the client. Seen by the client. Okay, it is the end-to-end wait time seen by the client. Or in other another terms, we can say it is the time between sending request and receiving a response. Okay, so this is the latency. Now let's understand the second term, that is throughput. That is throughput. So let me write throughput here. Throughput. If you guys are kind of nerd and have some interest in physics, then you would probably know a term or a definition that we call rate of doing work. Rate of doing work, right? Rate of doing work. What does it mean? What does rate of doing work? Like how much work is done per unit time? Per unit time. Or we can say work done per unit time. Right? This is rate of doing work. This is rate of doing work. So in computer science, what do you understand by doing work? What do you understand by doing work? It simply means how much request our server is capable of successfully responding to, right? How much request our server is capable of successfully responding to. it is doing work. It is doing work for a server. So in terms of computer science, we can say throughput is nothing but it is the number of requests or messages a server processes during a specific interval of time, right? It is the number of requests a server processes during a specific interval of time, or I can say number of requests processed per unit time. This is what our throughput is. This is what our throughput is. It is the number of requests processed by server during a specific interval of time. This is throughput. Our latency was the end-to-end wait time as observed by client, and throughput is the number of requests successfully responded by our server in a specific interval of time. Okay. Then you will ask, why are we studying latency and throughput? So whenever we are designing a system, our goal should be that our new features should be as fast as possible. Like we want to provide clients a smooth user experience, right? Then our aim should be providing that a new feature should be as fast as possible. That is, latency should be minimum, right? Our goal should be latency should be minimum. Latency should be minimum, right? This should be our goal while designing a system or while creating a system. And for throughput, what should be our goal? What should be our goal? Our goal should be that our server should be capable of responding as more as possible requests. Then our system should have high throughput. Our system should have high throughput. High. Now that's okay. That's okay. We want minimum latency and maximum throughput. Now the question arises. Now the question arises: how can we check the latency and throughput of our system? Of our system. So let's start. Let's first start talking about how how your code reaches production or end user. Let's discuss this. Let's discuss this. That how our code reaches production. We just write our code in code editor, create a PR, merge it, then it's done. But what happens at the back end? What happens at the back end? What's the whole process of that code being available to end users? So let's start. Whatever what we do, we have developers like you and me. We have developers like you and me. Developers, right? What we do, what we do, we just create a PR pull request after, uh, or let me write it here. We do mm, write code, write code, test on unit test cases, write unit test cases. We write our code and test it over unit test cases. And I guess in most of the organizations, developers are the ones who write unit test cases. When unit test cases are successfully being run, then what happens? We raise a PR, and someone from our team, someone senior from our team, reviews that PR and approves it. After its successful approval, what we do? We merge PR. Then what happens? That PR goes to Then a DevOps pipeline will run. DevOps pipeline will run in which whole testing and build is being done. And after that, our code reaches to somewhat we call dev environment. Dev environment. Okay, it reaches dev environment. What happens in most of the organizations? A QA development or deployment exists weekly or bi-weekly. Weekly or bi-weekly. So after environment, your code goes to QA deployment or QA environment. I can copy this only. Just allow me a minute. Then it goes to QA environment, quality analyst. Also, few organizations don't have a QA environment, so they do all kind of testing in dev environment only. So let's say you have QA environment in your organization. What happens in QA environment? All your feature testing, smoke testing, and all this stuff happens in QA environment. Or let's describe this in detail. What happens? Suppose you create a button. This is your mobile. You are creating a button for mobile screen. Let's say here is your button somewhere. This is your button. Let's say then on QA environment, what happens? Testers test this. That's the UI of this button. That's the functionality of this button. They will check is this button working properly or not. So this all thing happens in QA environment. After proper testing, your code is being deployed to stage environment. Is being deployed to stage environment, right? And the process of deploying this code to stage deployment is called as staging. What happens as environment is a, it's similar to production environment. It's similar to production environment. Suppose on QA environment, you may have only a single server. You may have only a single server. But in stage environment, we try to mimic our production. We try to mimic our production. Whatever is required, Redis cache or multiple servers or load balancing, whatever is required, we deploy that. Okay. Then what happens is stage environment, we have to check some what we call performance testing. Performance testing. Or we have to do something called security testing. Like we have to do like whether our system is secure enough or not, or it may easily be hacked or not. We have to test this. Okay. In a stage environment. And after all these testing, it is being deployed to production. It is being deployed to production. Production. Right. It is being deployed to production. It is being deployed to. So this is the whole flow. Your code goes to production. Firstly, you will develop it, write code, write unit test cases. Then someone will approve your PR. Then after the PR is being approved, it goes in DevOps pipeline where the build and other things happens. Then it goes to dev environment on a weekly or bi-weekly basis. Let me write it here: weekly or bi-weekly. Weekly or bi-weekly basis, it goes to QA environment. In QA environment, on all the feature testing, smoke testing, and other thing happens. Then it comes to environment, stage environment, staging is being done. And in this, we do performance testing, security testing, and all other related stuff. After it is being successfully done, the code is being deployed to production. The code is being deployed to production where the end users are able to access it. End users are able to access it. and users are able to access it. Okay, let me remove it. So this is the whole flow. Your code goes to production. Now, in this lecture, what we are going to do, we are going to do something called performance testing. We are going to test our system or server, its performance. We are going to test its performance. Okay, performance. Right. We are going to test its performance. So let's start with the performance testing. Let me write it here. We call it performance. I guess the spelling is wrong. We are performance testing. Okay. What do you understand by performance testing? What do you understand by performance testing? It is it basically means testing the performance of your system. It should basically mean the testing of a performance of your system, like whether a system is capable of handling this user load, this request or not. So let's write it here. It is it means testing the performance of a system over various scenarios. Over various scenarios. It is performance testing. There are several kind of performance testing. There are several kind of performance testing. We shall be understanding and actually having hands on over few of those types. So let me write it here. Few types of performance testing. Types of performance testing. PD. Okay. So the first type we shall be discussing is load testing. We shall be discussing it load testing. Load testing. Another type we shall be discussing is spike testing. It will be spike testing. And the third type of performance testing we shall be performing will be stress testing. Stress testing. Okay. So let's first understand each of these types. Each of these types. So let me write it here first. Load testing. Load testing. What does it mean? Load testing means testing your system over average day load. Testing your system over average daily load. Testing your system over average daily load. Suppose you are getting somewhere around, you are having 10,000 users each day on a normal basis. There is no special day. Then you shall be testing your system over that load only. Over that load only. That is load testing. Okay. Then we have another type called spike testing. We have another type called spike testing. What does spike testing mean? It means testing your system over a sudden spike. It means it means testing your system over a sudden spike. What does spike mean here? What does spike mean here? So let me quickly draw a graph. Let me quickly draw a graph. I can use this one. Yeah, this is my graph. Okay. And this axis denotes what? It denotes uh, time. It denotes time. And this axis denotes number of users. Number of users. It denotes number of users. Okay. Suppose you are having something called initially you are getting a constant user load. You are getting a constant, and something big happens. Suppose you are engineer at Twitter, and a big news happens. A big news happens, whatever it may be. It may be around cricket, sports, politics, and whatever world news. Suddenly, number of users increased on your platform. On your platform, suddenly within few seconds, within few seconds or minutes, within few seconds. These are a very negligible time, right? Few seconds. Within few seconds, number of users drastically increase over your system. Then suppose user load remains same for few seconds, and then users found that it was a fake news. Then users found that it was a fake news. It was a fake news. Then they have to leave the system, and drastically they leave the system. And now your system has average day load, average day load, no issue. So what is this? What is this? This we call spike. This we call spike. It is a sudden spike. This is a sudden spike. We call it spike. We call it a spike. Spike. So in spike testing, or I should bring this all a bit lower. Yeah, it's fine now. It's fine now. So what we do in a spike testing, we test our system over such kind of scenarios when we drastically increase number of users on our system for few seconds, and then we quickly drop the number of users or number of requests. This is known as spike testing. During that testing, we have to check whether the system is capable enough of handling this kind of scenario or not. This is spike testing. This is spike testing. Then the third one is stress testing. Then the third one is stress testing. Stress testing. What we do in stress testing, suppose our number of users, we are targeting 5,000. 5,000 is the user load at any instance of time. 5,000 users. Okay. What we will do, what we will do, we will first test our system over 5,000 users. We will test our system over 5,000 users. Then what we do, we will increase number of users. We will test it over 10,000 users. Then we will test it over 15,000 users. Then we have to test it over 30,000 users. And then we will test it on 50,000 users. And suppose at this point, at 50,000 users, our server breaks or crashes, our system crashes. What we found that our system is capable enough of handling less than 50,000 requests. 50,000 is the threshold. 50,000 is the threshold. So in stress testing, what we do, we try to find the peak load a single server can handle. We try to find the peak load a single system can handle. So let me write it here. What we do in stress testing, we gradually increase number of users and try to find the peak load a single server can handle. We try to find the peak load a single server can handle. Okay, but what will happen? Suppose we find the peak load is this. Peak load is this. Above this, our system or server should not will not be able to handle more load. Okay, then what? Then nothing. We will know that this is the threshold, and in any case, we see that number of users may increase than this, may increase than this. Then we will already be ready for that kind of scenario. We shall only be ready for that kind of scenario. We might be setting up, we might have already set up auto balancing, or we already had some warm state servers, whatever. But this is the threshold, and after knowing this, we will be ready to handle if any worst kind scenario, any worst kind scenario. So what? Why we do testing? We do it to identify the breakpoint, to identify the breakpoint. We do it to identify the breakpoint. Okay. Now, what we shall be doing? Is it enough? No, it is not enough for a lecture. We shall be doing hands-on, and we shall be performing all these tests over our server, over one of our servers. So let's start for the load testing, or spike testing, or stress testing. Okay, so firstly, to test, we need a server over which we shall be testing it. So in our last video, I created a server, a IP server that returns IP address. Let me show it to you. It's inside my projects directory, and I have somewhere. This is the IP server, cd IP server, and I will open it in VS Code. And yeah, this is my server, and it listens on port 3000. And what it does, it returns the IP address of the hosting machine. It returns the IP address of the hosting machine. So let's test this first. I am starting this server node index.js, index.js. Yeah, the server is running on port 3000, and let's test it. I shall be going on localhost 3000, enter, and yeah, it's working fine. It's returning me the IP address of the hosting machine. It returns me the IP address of the hosting machine. Now, what we shall be doing, we shall be performing performance testing over this server. Over this server. For doing performance testing, we shall be using a commonly used library, which is K6. K6. Let's read a bit about K6. This is the documentation. Let's go to documentation and let's read about it. Uh, it's provided by Grafana. Grafana K6 is an open source, developer friendly, and extensible performance testing tool that helps you catch performance issues early and proactively improve readability. So it's provided by Grafana, it's open source, and we shall be using K6 for doing performance testing. So let's go to setup part, and let's see, we have something in install K6. We shall be installing it on Windows. So we have a command here, choco install K6. I shall simply be running this over my machine. Let's open another prompt, and I will copy and paste it. Choco install K6, and it um uh, yeah, it's installed. It's installed, no issue. It's a warning, nothing else. Oh, sorry, it's asking, do you want to continue or not? Yeah, continue. Uh, yeah, it's downloading. Let's wait for a while until it's being fully downloaded. We can use it using Docker also. We can create a maze in Docker and use it there, but no issue. We have downloaded it in our Windows machine only. What else? Configure your code editor. Okay. It's still being downloaded. Let's read a bit more about this. Let's go to this link, K6 JavaScript API. What is inside this? Nothing much. K6 browser. It's of our use, I guess. K6 HTTP. Let's see. Uh, K6 not installed. Unable to open log file. What happened? I guess I have already installed it. Yeah, I already have K6 in my machine, so no issue. You can uh, use ChatGPT or anything else to install it. There is that will be a cup of cake, not a big issue. I already have it in my machine, so let's continue with this. So what I will be doing, I'll go to my directory and inside project folder only, I will be creating a new directory called performance testing. Okay, I will enter into this, Control C, Control V, and I will open it in my code editor. I will open it in my code editor, and yeah, it has been opened. It has been opened. Uh, then I shall be creating a GitHub repository for it also. Let me create a GitHub repository quickly. I'm going to my repositories. I'll create a new repository, then creating known as performance testing. Okay, and create repo. It has been created. I will do git init, git status, nothing to be committed, and I will git remote add this origin of this repository. Yeah, it has been added. Let me refresh it. I don't have any file yet, so okay, no issue. So firstly, we shall be doing load balancing. We shall be doing load balancing. So let's create a file. Load, load testing, not load balancing. Sorry for the issue. Uh, it is load testing. Okay. Then we shall be going to the Grafana documentation. We will be using get started and go to write your first test. Um, we have to import it. I will copy it and paste it in my code editor. It has been imported. Then let's first understand what else we need to do. These are options. Okay. I have to create a function and define my endpoint here. Define my endpoint here. So let's create a function export default function, and we have already imported this HTTP module. We shall be doing http.get, and we shall be hitting testing our localhost 3000 port. Okay, we have made this function. But now we have to define the number of users or number of requests. So we what we do, we define something called options object here. So we will define objects. Export const options, in which we will define view as and duration. View as and duration. Let's do it 10 seconds. Let's understand what is meant by VUS. What is meant by VUS? I will start the basics. Case. Okay, K6. What is meant by VUS in K6 options? VUS. VUS simply mean virtual users. Virtual users. Now, what will happen? I have defined these options. When I will run this file, it will go to this endpoint. I have to write. Yeah. It will go to this endpoint, and 10 users constantly for 10 seconds will be hitting this API. Will be hitting this API. So let's start this. Let's start this. I guess the script is K6 run. K6 run. And the file name is what? Load testing.js. Load testing.js. Request is failing. Don't know why. I guess my system is, oh, 100% of the requests have failed. Why? I have defined a wrong endpoint or something. Let's try defining this. It is get method. Yeah, get on slash. Mm, okay, what could be the issue? Okay, let's try starting the server again. Let's start the server again. Node index.js. Okay, let's try running this script again. K6 run load test.js. It's again failing. Let's try reading the error message. Server gave HTTP response to HTTPS client. Oh, sorry, I have written the HTTPS here, but we have not done SSL part yet. So I will done HTTP only. So that was the issue. Let's try running that again. I was simply using HTTPS, but we have to use HTTP. Okay, let's try this. Running this again. Yeah, it's working fine. See, number of users are running for these seconds. It will run for 10 seconds. These are the number of requests. These are the yeah, it has been completed. So let's try understanding this response. What does this response mean? See, it is showing 100% then that all the requests have successfully been responded by our server. Maximum number of virtual users were 10. Okay. Now comes to this HTTP part. Let's understand this. It is showing us average. These are the successful requests. So since our all requests were successfully responded by server, so these two will be same. Okay. So this expected response true. It denotes that it tells us the stats of our successful responses only. It is telling her average is 52.37 milliseconds. So what does it mean? That average latency of our server is this. What is latency? The time client has to wait. The time or the wait time of client is latency. So when client initiates a request and gets back a response, that is latency, and that average for requests, all the requests are, see, we had 10 users initially, and they continuously keep requesting the server for 10 seconds. So within that 10 seconds, they made these much requests, 1907 requests. Okay. So the average latency or response time of those requests were 52.37. 52.37. Suppose one, and the minimum time was 5.42 milliseconds. That one request, among these requests, one request was responded in this much time. It was the minimum, and maximum was 128.98 milliseconds. It was the maximum for a or for a request. Among these requests, 1907 requests, one such request was that has this maximum this much latency, 128.98. Okay. So average was the average of all, minimum was the fastest response, fastest response, and maximum was the slowest response. Maximum was the slowest response. Now understand these terms P9 and P95. P9 and P95. So let's come here. Let's understand P9, P90, and P95. P90 and P95. Suppose we had 10 requests. We had 10 requests, and let me write the latency or response time of them in sorted order. Suppose first one was it was 4 milliseconds. Okay, first one was responded in 4 milliseconds, 4 ms. Then another one was 5 ms. Then 10 ms. Then 10 ms. Then uh, again we have 15 ms. 5 have done. Then 45 ms. Then we have somewhere called 50 ms. 1, 2, 3, 4, 5, 6, 7. 7 had been done. Then 60 ms. Then again 60 ms. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do it 75 ms or 75 ms. Okay. And then the last one was when one request was responded in 300 ms. 300 ms. Now let's find average of them. Let's find average of them. I will open my calculator, and will find the average of them. We'll find their average. Where have they gone? Uh, to it. These were 4, 5, 10, 10, 15. 4 plus 5 plus 5 plus 4, 5, 10, 10. Sorry. 4 plus 5 plus 10 plus 10 plus 15 plus 45, 50, 60. 45 plus 50 plus 60, then 75 and 300. Then 75, then 300. So total is 574. Now if I divide it by 10, we had 10. Average is 57.4. Average is 57.4. 57.4 milliseconds, right? But is the average only thing on the basis of which we can judge the performance of our API or server? No, because many of the requests are being done within 45 milliseconds, or suppose it was 1000 milliseconds for one request. Suppose anything may happen, network latency or whatever, then it might go above somewhere around 150 milliseconds. So suppose it's 150 milliseconds, can we judge our application that average is 150 ms and then it's slow? No. But most of the uh, requests are being responded within 45 milliseconds, 50 milliseconds. So what does P90 tells us? What does P90 tells us? Suppose let's do it 1000. Let's do it 1000. Let's do it 1000 only. Last one is 1000. Suppose. Then let's do this 150. 150 ms. Now I will say that the average response time is 150. Then most of the requests are being has the latency of 150 milliseconds. No. What does P90 tells us? What does P90 tells us? It tells us the maximum latency of 90% of the top requests. 90% of the top requests. Suppose these are the 90% of the top requests. So what is the maximum latency of them? It is 75. It is 75. So what does P90 tells us? It tells us P90 tells us within what latency or maximum latency our top 90% of the requests are being responded. Like, what is the maximum latency of 90% of the request? This is what P90 means. It is 75. And if we say 150, no, more than 90% of the requests are being responded within 75 milliseconds. Similarly, what does P95 signifies? It signifies the maximum latency of 95% of the requests. 95% of the requests. So in this response, P90 is what? It is 65 millisecond. It is 65 millisecond. That what does it mean? That 90% of our requests have the maximum are responded within 65.12 milliseconds. And what is P95 for it? It's 74 or 78 milliseconds, which means that 95 top requests are being responded within 74.78 milliseconds. Right? Then we have HTTP request failed, 0. No request is being failed. Total requests were 1907. No request is being failed. Total requests were these one. Right? And these are the same stats here. Uh, okay. These are the virtual users. Minimum were 10 and maximum were 10. Like always, we had 10 virtual users. Okay, this much data is received, this much data was sent, this much data was sent. So these are all the stats. Now let's do something else. Let's do something else. Suppose we are doing load balancing, right? We are doing load balancing, load testing. We are doing load testing. Suppose number of users, we are somewhere have 100 users, and let's test it for 20 seconds. Let's test this for 20 seconds. Let's see what happens running it. Now it will run for 20 seconds and the number of users are 100. Number of virtual users are 100. Let's see what happens. Yeah, it's done. Now see, average duration is what? 480 milliseconds. And earlier when we had only 10 users, it was 5 to 52 milliseconds. Okay. The total number of requests were 4215. Earlier we had only 1907 requests. And what is P90 in this case is 552 millisecond. 552 milliseconds, and earlier we had 65 milliseconds. And it's 603, and earlier we had 74. What does it mean? That CPU is having more load. CPU is having more load. That's why it is taking much more time than earlier to respond. To respond. Okay. What is our throughput? Our throughput is, see, these were our total request 4215, and the total time was what? 20 seconds. So this is our latency, that 205 requests. Sorry, this is our throughput. 205 point this much requests are being responded per second. This is our throughput, and maximum, these were 100 and maximum user was 100, and this was the data received and data sent. Let's increase number of users to 1000 now, and it's for 10 seconds. Okay, let's see what happens. Let's see what happens. Oh, it's failing. My system is not capable of handling 1000 requests. Okay. Uh, see, 97. I have stopped in between, but most of the requests are being failed. Like my current system is not capable of enough of handling this much request. So let's do it 500. Let's do it 500, and keep it 15 seconds from now. Let's again. It's failing. Let's see what's the response now. How much requests are being processed? And the error I was getting is connection could not be made because the target machine actively refused it. My machine was not capable enough. My server was not capable enough. So see, this much requests were failed. Like out of these much 63 requests, 63,934 requests, 61,831 requests were failed. Okay, so this is the data of all the requests. The data of all the requests. Uh, okay, the latency is too low when compared to this. Why? Because most of the requests are being failed. Let's see this data. This is the data of successful requests. This is the data of successful requests. So the average latency of this much, P90 is 7 seconds, not milliseconds, it's second, and 95 is 12 seconds. See, so suppose uh, my target user is like normal day-to-day user. Since we are doing load testing, we do average daily load. Suppose the average daily load is 500 users, then my server is not capable enough of handling this. It is the clear signal that I need to scale it up, or I need to do something so that it is capable of handling this much request, right? So this was my load testing. This was my load testing. Let's move to spike testing now. Let's move to spike testing now. So firstly, let me commit this. I will attach the link to this repository. Um, uh, Git status. I will do git add all, git commit -m added load testing, git push origin, or I have to create a new branch, git checkout -b main is the name of my branch, git push origin main. Okay, it should be there. Let's see. And yeah, load testing.js file is here. I will attach the link to this repository in the description section so you can try it out. Now let's move forward to spike testing. Let's move forward to spike testing. Okay, I will create a new file called spike testing.js, spike testing.js, and I will copy it and I will paste it here. Now, uh, see, we have a dynamic kind of user load. Suppose initially we have lesser user load, then user load increased, then user load came down. So this configuration will not be quite enough for me for spec testing. So I need a dynamic configuration. For that, what I will do, I will define something called it pages here. It will accept a array. In this array, I can define this type of configuration. Let's accept the suggestions by Copilot. What will happen in first 2 seconds? The target is 100. Now understand this is not VUS. Earlier we had in load testing we had VUS, virtual users. Now that it's target. So what is the difference between two? In virtual users, the users will remain static 500 from initial point to final point. The users will remain 500. But when we define it as target, it means that it will start from zero, number zero. Then within these 2 seconds, it will keep increasing the number of users. It will keep increasing the number of users. And apparently, after 2 seconds, at number of users will be 100, then 0, 5, 10, and then 100. Okay. Then in next 5 seconds, the number of users will remain 100, will remain 100. Then in another 2 seconds, it will move to from 100 to 200. So let's see. We want something this kind of spike. So let's see. Initially, for 5 seconds, we have a lesser number of users. Suppose the number of users were 10. Suppose the number of users were 10 for 5 seconds. Then within 2 seconds, what happens? A spike came up. A drastic increase in users came up, and target is 100. Let's do it 200. if my machine is capable enough of handling this much user load. Okay, for next 5 seconds, or let's say next 3 seconds, it will have 200 users. It will have same number of users, and then within next 2 seconds, the number of users suppose become zero. Not this much. Suppose it will become zero. Let's test it over this configuration. For first 5 seconds, it will be 10. Then within next 2 seconds, it will go to 200. Then for next 3 seconds, it will remain 200. Then within 2 seconds, within 2 seconds, they will come to zero. They will come to zero. Let's test it for this scenario. Let me do clear a screen first. And it's K6 run, and the file name is what? Spike testing.js. Spike testing.js. See, for first 2 seconds, we have within first second. Now another 2 seconds, we have 200. Then it will remain. Then it will come out to zero. And it was too quick. It was too quick. Okay. Let's see what happened. Let's see what happened. Uh, Surprisingly, all our requests have been successfully been responded by our server. And now we see the average latency latency is 450 milliseconds, 450.89 milliseconds. And minimum is 3.53 milliseconds. It's too fast. Uh, it's too fast because initially, at the initial time, we have comparatively a lower number of users, suppose 5 or 10 users. Initially, we don't have 200 users because we have target here, not VUS. So it is that fast. Maximum is 2.15 seconds and medium is 354. Let's understand the P91. It's 1.02. It's 1.02 seconds and P95 is 1.04 seconds. What is the throughput? It's 198.96926 seconds. Sorry, request per second. It is the throughput. And virtual users at our instance, we had minimum 2 virtual users and maximum it went to 200. Maximum it went to 200. And yeah, and this was the data received and data sent. Let's try some more configuration around it. Um, how can we do? Uh, like that was the spike testing. Okay. Okay, that's enough for spike testing. Let's see some failing scenario. Let's see some failing. Suppose the user load went to 500 and it went to 800 within next, sorry, 800, not 80,000. Okay, then it will come out to, okay, for first 5 seconds, it will be 10. Then within 2 seconds, it will go to 500. Then next 3 seconds, it will go to 800. Then within next 2 seconds, it will come out to zero. Let's see how my system or server responds in this case. Uh, it will be 10. Now it will go to 200. And yeah, my server starts filling the requests. My server starts filling the request. Let's see what the response. So see, around 90% requests have been failed. And for the successful response, these are the stats. And it's 1.16 second average time. This is this. This is this. Minimum users were 2. Okay. Suppose we can do it 200. Then we will go up to 400. Okay, let's see what happens in this case. Firstly, it will go to 10 seconds. Sorry, 10 users, then 200 users. Then it will go to 400 users. Oh, hopefully, no request is being failed. Yeah, no request is being failed. Yeah, these were the total number of requests. This time, the average latency was 724.82 and P90 was 129.2s. 29s, and this was P95. Okay, minimum users were 2 and maximum were 396. At maximum at this area, maximum users were 4, 400. Okay. This is the data received and data sent. Okay. So this was about spike testing. You can play around it. You can play around it. Let me commit this file also. Let me commit this as follow git status, git add all, git commit minus m added spike testing, git push origin main. Yeah. Now let's look at the stress testing. So stress testing. Okay. Let me create a new file. Stress testing dot. Yes, and let me copy and paste it here. Let me comment down here stress testing so that Copilot will recommend the options here for stress testing, right? No, this is not a stress testing. Uh, Control that. We can define stages here. What we will do, we will for 20 seconds we will make our target 400. We will gradually increase our load. We will gradually increase our load. Oh, there is some syntax error here. Now it's fine. For 20 seconds, initially it will be 0 users, then 1, 2, 3, and for next 20 seconds, our target will be 400. We will reach out to 400 users. Let's see how it will work in this scenario. A6 run stress testing.js. Stress testing.js. It will go to 400 users, 80 users, 90, 100. Yep. It's going fine. It's going fine. 300, sorry, 250, 300, 350, and yeah, 400, 400. Now it's coming zero. Okay, up to 400, looping virtual user for 220 seconds over one stage. Okay, all our requests got processed. This was the what latency you can consider it, and this is the throughput. But in stress testing, we have to find the breaking point. So let's increase the user load to 500 now. 500, and let's run this again. Let's see, will it be able to handle this much user load or not for 20 seconds? Da da da, 400 cross, 450, and yeah, it crossed 500, 500 looping. Again, it is successful. It is successful. Okay, let's try giving it 600, 600. Yep, let's see now what happens. Yeah, 200, 250, 300, 350, 400, 450, 500, 550, 600. And yeah, it worked well. It worked well. Let's try giving it 800 now. 800 now. And yeah, time also makes a issue. If I do it 2 or 3 seconds, then yeah, definitely these much requests will fail. Okay. And yeah, 800 is our failing point for 20-second time. That's what we were looking at. Now it's working. And yeah, around 83% got failed. So we can consider 800 as our peak load, 800 as our peak load. So let's try for 700 also. Let's try for 700 also. 250 cross, 300, 350, 400, 450, 500 cross. Until 600 it was working fine. Okay, 600 cross. Um, yeah, it paid for 700, somewhere around 700. Yeah. 8% request got failed. 8% request got failed. Let's try giving it what? We can try giving it 670. 670. Let's try it this time. Until 600, it's working fine. Okay. Let's see. 300, 400, 600. Let's see that thing now. Oh, 670. It worked fine. It worked fine. Let's try giving 680. Let's see if any request fail or not. But in that scenario, we already, like initially when it failed at 800, we might have some log where it was telling that for what user load it failed. But okay, let's try for 680. I guess it will fail this way. It will fail now. Yeah, it failed for 680. It failed for 660. Yeah, 11% request got failed. So see, 670 is the peak load it can handle for 20 seconds, right? So this was all about stress testing. In the next video, if I feel that I should play around this stress testing, let me commit it first. Let me commit it first. Um, Get a status, git add all, git commit -m, add it. It's stress testing, git push origin main. Yeah. So in this lecture, what we did, oh, we firstly understood latency. What is latency? It is the end-to-end wait time seen by the client. Okay. Then we understood throughput. What is throughput? It is rate of doing work or the number of requests processed per unit time by server. Then we understand how our code reaches production. Developers merge it, goes to DevOps pipeline, then dev environment, then QA environment, then feature testing is done at QA environment, then staging, stage environment, and at the stage environment, usually performance testing is done. Usually performance testing is done. Then we saw what happens in performance testing. So these are few types of testing done during performance testing: load testing, spike testing, and stress testing. Then what is load testing? It is testing a system over average daily load. Then spike testing is testing our system over sudden spikes. Then what is stress testing? It is about finding the peak load of a single server at an instance. Okay. Then we had a hands-on over these type of testings using K6 provided by Grafana. We understood this response provided by it. What does it mean? How we can configure the K6 configuration file. Okay. Now there is a task for you. What you have to do, take this file from GitHub repository I mentioned in description section, and you might somewhere in your career have developed some API, right? I developed this IP server API. You can test it over any API. You can test it over API, and I want you to test it. I want you to test it, and I want you to understand all these terms, whatever written here in deep, in deep. Do Google, do ChatGPT, do any other AI, use any other AI tool, whatever you want, and understand these things and play around it. Play around it. In next lecture, if I feel good, if I feel that I should also play around this, then what I shall be doing? I shall be introducing couple of or more than that interesting scenarios where initially I have a single this API only, this get API. What I can do, I can have something where we have to fetch data from database, we have to connect some third party application in which there is which is more time taken. I can introduce such kind of APIs, testing on such kind of APIs. I can have more a good testing scenario, good testing scenarios, like more complex testing scenarios. So I will try to get it, but I want you to play around it. Okay. So I hope you all enjoyed this session, today's session. It was fun for me. Even if, uh, at least it was fun for me. I hope it was fun for you too. Then let's meet in the next couple of sessions, next set of lectures. Until then, I want you to keep exploring, keep learning. Bye bye.